Hello and welcome to another Developer Essentials. So this time around, what we want to take a look at is working with builds. So we've seen a lot for working with our projects, getting things up and running in them, but one of the crucial things we want to do is look at how do we then turn that into an actual build. So the process for this is generally similar across the different platforms, but there are some variations there. So I'm going to be showing a little bit of this and I'll talk about some of the things that are different. So the process for building is if we go to build and we'll take a look here, we can go and we see under build settings, that's actually the starting point of where we want to take a look at with this. So we can see the different platforms that we have potentially available. And what you might see is this, where some platforms we won't have actually installed them. So we need to be able to select them here. So for example, in this case, although this is PC, Mac, and Linux standalone, I haven't installed the Linux compatibility support, so I only can choose Windows and Mac, because those are the two ones I've installed. So which ones we install controls which ones we can see here. If we need to modify it, we can go to Unity Hub and change that though. So same for all of these other ones. A lot of these, they won't necessarily be there. Some of the projects actually require a particular license. So this is a common thing where you'll see with consoles, where you need actual license to be allowed to submit on that, which often requires compatibility from or provided by the platform holder. So in this case, Sony or Microsoft in the case of Xbox, or also Nintendo, ones like of that. Android will work for your devices like also not just phones and tablets, but also things like an Oculus Quest or Go, any of those ones, the Android builds will be what you're after for that. So here's where we can select what we're building for. And so we can switch between different platforms here. And then we can also, one of the first things is, at the moment, I don't have any scenes in the build. So we have to specifically provide what scenes are in our game. And it will only build scenes that are there that we have provided. And the order matters, but the order matters really only for the very first scene there. The very first scene, that is the one that Unity will load first. So if we have a main menu or a splash screen, something like of that, that is the scene that has to be first. But any scene that we want to have available to us must be here in the scenes in build. So I can go and tell it to build. And we can see what's going to do that. I usually will put all of the builds under a specific builds folder. And the other thing I will also do is I will usually split it up by platform. Just means that it's easy to group the particular ones. So I can say, okay, it's going to go into the Windows one, and we'll tell it to build that. Let's see what that looks like in terms of what we get for the output. And so the process in this case is going to be pretty quick because there's very little happening in the project. But we want to see what we actually get with this. In some platforms, it might take longer to build for. So in C, it's set it all up here. This is what I would then zip up. So what I would do is I wouldn't want it set up like that. What I would normally do is if I go to build, then I would actually create an empty folder under here that this would be demo build. So this would be the name of your project. And then we build it there. Now, generally, rebuilds will be fairly quick, especially if it's overriding in the same folder. And we can see, well, it's already gotten a name here from this. What if we wanted to change that? So we can go to our player settings. So this controls a bunch of things. And there's a couple of key things here where we can control things like our icon. So if we want to give our project an icon, we can set that here. Now, if we need to do further customization based upon resolution, which you might want different icons for really small resolutions that have less detail. Otherwise, it will just scale down the one you provided or scale up. We can set our icon and cursors. And we can customize this in terms of stuff like our company and product name. So product name determines that executable name there. So that's something you typically want to customize. Version is something we'll come back to, we'll be looking at in a moment. Company is an important thing. That's going to control where your files get grouped, so when it's storing data. Because one of the things with our projects is they need a place to potentially store data. If you're working with save games or settings, things like that, we need to have somewhere where we store them. So that gets stored in something called the persistent data path. So what I could do, just as a way of seeing what that is, so I can access application.persistent data path. That will tell me where it is storing data out to. So I'll be able to see if I run that, it's going to log out. So I can see it's based upon the company name and the project name. So company name matters, product name matters. Those will control where data gets stored. So those are the main things we're typically changing there. There are other settings we can change here under the player settings. So resolution allows us to control a bunch of different options in terms of how things are being presented. Splash image, this might be, so if you're using some third-party software, some middleware, some of those will often require that you provide a splash screen. So you can provide that here. You can customize a little bit of how those appear. We also have then under other settings, these are going to be ones that are more often performance or low-level related. So for example, a setting we'll often turn on is dynamic batching. That way objects that aren't marked as static can still be grouped into batches for better rendering performance. And we can control other settings here in terms of, these are ones that are more specific to things like Mac or iOS, where we're setting the particular name and build number information we can control. And we can add in a bunch of extra sort of settings here. So these are sort of our low-level ones. We're often not needing to change them much. But key ones initially are going to be things like our company, our product name, the icon, stuff like that. And so, okay, well, we know where our data is going to get stored. What about getting information back from a build? Because we have done this build, and so I've got this, and I could run it, and it's not going to do particularly much. We get our splash screen, and the version number is not really doing anything at the moment. And I can exit it, but that will have actually logged information out. So we can find where our logs are stored. So where they are stored does change with the platform. That's an important thing. Where the logs get stored does vary based upon the particular platform, but that is something where I'm going to put a link in the description below so that you can see where those log files actually get stored. So let me load up the particular log files, which the persistent data path is usually going to get us pretty close to where the log files are. So if I head over to that path, then we can see the log file. And in this case, there's not particularly much that it's going to be showing because the project is not doing very much, but this is something where if you were getting problems and you're trying to track those errors down, then you can access those log files. That's something that you could get, if people are submitting a bug, you could get them to pass that log file to you so you could then try and check for any errors, any exceptions, things like that are occurring in it. So builds, the log files will go in a particular location. Output from the console will typically go there as well. Now, with builds, we can actually make a version of a build that is more debuggable. So we can have development builds that will then allow, and if we turn on development build, that enables things like being able to do debugging, being able to turn on profiling. We can have a build that's just doing the compilation. It's not processing any assets. So it gives us different ways of being able to work with the build to be able to iterate on it quickly. So, okay, we can do a build, We can set our company information. We can set things like our version. But I mentioned I want to do more with that version. I do have this display here because that's a thing you might want to access in code. So we can do that. So our version display text, I can set that to application. And we've got the build version. We can also access the Unity version if we wanted to as well. Again, if we had our own bug reporting thing, that could be a really handy thing to do. So we can just have this, it'll display whatever version we've got set, which we could see in our project settings for the player. We set that as 0.1. Really important thing when you're working on projects, I do recommend having that version number be there, something that's very easily, clearly visible for your testers, your players, developers, because it's really important to know what version an issue has occurred in. And in particular, if you think you've fixed that and you see it again, you want to know, okay, is this because they've got an older build, or is this because the problem hasn't properly been fixed or has reoccurred? So version numbers, super handy to have in there. So, okay, we can create builds. We know we need to add in scenes. We can find where we're storing data. We have a location we can write to. We have a setup there in terms of we can be seeing the log files. We can get outputs. We can change our version number. What about if we want a file to just be copied over alongside the build? Because if we take a look at the build that gets produced, we have this data folder and everything is kind of just packaged up. We've got these different folders, but everything's just kind of packaged together. We don't have standalone separate files. What if we wanted something that was a standalone file? Well, that's where this streaming assets folder comes in handy. So streaming assets, I'm going to create a file in here, create new text document, demo document. And so Unity's seen it. Now, one of the things that we will notice then is we go into a build. So build settings, do a new build. We're overriding in that folder. And we'll go through to its process. And then what we can do is we can see streaming assets, it's just been copied over. So if you have some custom file format, something that's not going through and being processed through Unity's normal asset processing, whether you're not wanting to go through that, you can put it in the streaming assets folder and that data will just get directly copied over. So you can have it just directly copied over, makes it easy to work with. You might then be thinking, well, how do I find that at runtime? We have streaming assets path. So that will be valid based upon wherever the project is running from. That'll give us that file path. So we can access our streaming assets path, and I will log that out. Streaming assets path. So, okay, streaming assets is great if we had custom data that we don't want Unity to process, that we're wanting to just work with. So for example, our levels might be set up as a text file, and we want to load that text file and parse it at runtime because we want users to be able to chuck in their own data. Streaming assets is the solution there for that. So that allows us to really nicely pass data through, to work with it, to be able to manage it. So, okay, can access version numbers, we can access the data path for storing stuff, we can have a location where people can drop files in at runtime and be able to access them. We have the ability to switch between different platforms. What about some things that can go wrong? So there's a couple of things that can really easily go wrong. So one of the things that can go wrong is editor demo. So the Unity editor stuff, which we might access if we're doing things like custom inspectors or for potentially other reasons, it doesn't exist in a build. So I'm going to create this Unity editor one here, and we'll see in Unity, when I'm not doing a build, running a build, it's fine. It's not cranky about that. And I'll make sure that's attached to an empty game object, just so that it's absolutely there. Let's try and build and see what happens. Because we'll try and build, and what will typically happen is editor stuff doesn't exist there. So you can get away with doing a using Unity editor, but if I tried to do more than that, so Unity editor, here we have a bunch of things in there. So like editor utility, and if I did something like checking if a particular thing is dirty, so if something has been modified. So this will run completely fine in the editor. You can run this, code will run. It's not going to cause any issues. What if I try and build? So immediately it fails. So although I can get away with doing a using Unity editor, that's fine with that not being accessible. But as soon as I try to access any editor code, you can see they don't exist. So scripts that are editor only, or that are accessing those editor only bits of code, there's two ways we can manage that. One option is by default, any file that is put in an editor folder, Unity will not compile it at build time. So it will be loaded when we're running stuff normally, but it won't actually compile it. So we can see, but this causes a different issue because this was attached onto something. And so that's not going to be happy with us, because we might want something where, well, it has some functions that run in the editor and some things that don't. So we can handle that though. What we do is we can ask if Unity editor. So what this is known as is, so these are preprocessor directives. We're doing conditional compilation. So when the editor is playing our code, when we're just working in the editor, this is going to exist. This is going to be defined, which means this code exists. Outside of the editor, so when it's doing a build, that will not exist. So it gives us a way of having code be able to be different depending on different conditions. This is a way that cross-platform stuff often gets handled. So you might have a function that is play sound, and for the rest of the code, for everything that talks to it, it just sees play sound. But internally, it might use these preprocessors to say, okay, well, here's the version I do for Windows. Here's the version I do for Mac. Here's the version I do for Linux. Here's the version for Android, iOS, different things there. So it allows you to present a single interface to the majority of your code, and you have one area that needs to care about different platforms or different conditions. So this is a really powerful way of being able to control what bits of code are running. And we'll see with this, it will be completely fine and happy in the editor here, and that code will exist and run. And even when I'm playing, that's typically going to be able to run. But the key thing is going to be, when I go to do a build, that will not be defined. Which means the code eliminates those lines. So it's effectively clearing out those lines when it goes and does a build, but it still exists here in the editor. So it allows you, if you need to have code that blends between the two things. So if you have code that is only editor, you can put that in an editor folder. So things like custom inspectors, custom editor windows, stuff like that would just go into the editor folder. Stuff that needs a mix of both, what you would do there is you would use these preprocessors for that conditional compilation. And we could see there's a lot of different ones that we've got available. We've got stuff where we can be checking, a whole bunch of different things in terms of what stuff's available. We can also check Unity versions. So if we have something where, okay, there was one way of doing this in one Unity version, but now there's a different way, we can use these version defines to check so we can actually make sure what we're running with there. So it makes it really, really easy for being able to, again, as I said, present a single interface to the majority of our code, which means our code's simpler and we write less code, and it confines the platform-specific stuff or stuff that's needing to do different things into one area. So really, really valuable. So those are the key essential things there with builds. We need to make sure we set our company name and things like that. We need to make sure that we are knowing where our files are going. So our persistent data path is going to be the main area where we can store data, where we'll have log files. Streaming assets is a way for us being able to provide data there that doesn't go through any conversion processes, that Unity just directly copies the file over, and then we work with that ourselves at runtime. So really handy process there for being able to transfer data. And when we're working with code, if it's editor-only code, just put it in a folder that's called editor. You can have as many of those editor folders as you need. So you can have just the editor code in that. And then for stuff where you need it to be a mix of both editor and not code, then you can use those preprocessor directives. And that's going to allow you to really control how the code's working and allows you to have the code be nice and clean and neat and avoid sort of build issues. So dive in and experiment. Take some of your projects if you haven't done builds for them and create builds for them. Test out how those builds go. Set up some cool icons for them, customize stuff with the splash screens, and just try and make them look as cool and awesome as you can. So yeah, dive on in. Folks, if you're looking for the code for the project, then you'll be able to find a link to that in the description below. As always, that code is stuff you can use freely, whether it's a commercial or a non-commercial project. And if you found the video helpful, please do chuck in a like and subscribe. Really helps out. And if you're looking for further ways to support the channel, I do have a Patreon, and there is a link to that in the description below. Thank you.